All right, good afternoon, everyone. My name is Richard Lippert. I'm from Peter MacCallum Cancer Centre in Melbourne, Australia. Thank you to the organisers for giving me the opportunity to talk about Janis. So this is a collaboration project between three institutes at Parkville Biomedical Precinct, namely Peter MacCallum, where I am, WeHi, as well as University of Melbourne, where hundreds of researchers are collaborating across different projects. And one of the challenges that we often face is they try to share their workflows, analysis workflows across all these kind of collaborative projects. And essentially what we notice from between these three institutes is they are running different compute resource environments. All the tools are being run through different setup. The workflow specification and workflow engines that they use are also inherently different. Some have moved to a bit more standardized specifications such as CWL or WDL, but some still use other stuff like BPART, Rufus, or more of the later generation like Nextflow, SnakeMix. And yet inherently, it makes it slightly harder to share, to enable the collaborations between these institutes. Requesting support from system admins can also be challenging. They refuse to support every single combination of all workflow engines out there. Trying to convince someone to move from one engine to another is also difficult due to the number of expertise that they've built over the years. So in that, saying that, we need some sort of a bit more absolute standards. And the question that we often get asked in the last few months is, if I were to build a new workflow now, should I go with common workflow language, or should I go with workflow definition language? On one side, CWL is supported by multiple engines, as the previous talk has mentioned. And on the other hand, WDL has offered an easier way to start because the language is easier for people that deal with genomics, which is what we do mostly. But on the other hand, only one big engine, Cromwell, supports WDL. So what we decided to do, because all our collaborators are going to use a bit of both, is we try to build some sort of middle layers to write workflow in Python that can programmatically generate CWL and WDL workflows. Building this in high-level language, so alpha use and extra benefits to do type checking, such as secondary files, which can be confusing for beginners that comes in. We also hope for this to extend beyond CWL and WDL to hopefully, once the translation libraries are a bit more matured, it will support maybe Nextflow or SnakeMix. I'm not very familiar with both of them, but hopefully there will be some work on that. And it will also be able to act as a schema or API for some other workflow clients, such as a graphical user interface or workflow interface that can use the Janis API to generate CWL and WDL. So small examples of how a Janis workflow looks like. These are very simple pipelines using only a single tool's BWA, mem. So what you do is you import Janis helper classes. You connect all your edges between your input and output. And what you do is you translate this to CWL. And what you get is you get a CWL files workflow as well as the CWL YAML input. You do exactly the same, you use the exactly same pipelines and translate that to WDL this time, and you got the similar representations, but in WDL format for both the workflows and the input. Essentially, Janis doesn't have its own engines. All it's trying to do is to translate you a CWL and WDL files that you can use whatever engines of your choice, that they will take care of all the executions for you. But we come into a different challenge. Trying to support multiple engines comes at a cost because all the different engines at the end of the executions use a different semantics for their tracking their progress, metadata collection, and troubleshooting. So for a successful runs of pipelines, it's normally pretty easy, but most of our challenge is on troubleshooting. But trying to pull all the troubleshooting logs between these engines are still not unified, at least in my experience. So instead of summary, Janis is still pretty early in the development. We make it public only recently, but our main goal is trying to make pipeline development a bit more portable, easy to use, still adhere to standards. We believe there are value to be added without having to reinvent the whole wheels, and hopefully it's modular and also extensible to other workflow specification language. In terms of progress, we have built a few cancer variant calling pipelines with Janis. They have been translated to CWL and WDL, tested across TOIL and Cromwell on 3 Australian high-performance computing systems and Google Cloud Platform. For our cancer pipelines, we tested with genome in the border samples. achieve 99% recall, and the numbers are all identical across combination of workflow specification and workflow engines. We have all the documentation up at Read the Docs. The source code are available at GitHub. All the translation libraries that we use can be used outside of Janis. There's Python CWL gen and Python WDL gen. We're looking for more users to test other use cases, and hopefully we'll be able to get more translation libraries built in the future. And with that, that's the end of my presentation. I would like to thank all people involved with build Janis, especially Michael, who did most of the evaluation and implementations of Janis. Thank you.
Where's it worked?